good weather today compared to what we've been seeing. Right, so as I often said, this is the 11th in a series on continuous delivery that ThoughtWorks has been doing on a monthly basis. The previous talks, there's been some pretty good talks there, and they're available online in kind of recorded formats, and also I think some of them have, or most of them have their slides to be downloaded. So definitely recommend if continuous delivery is something that you're kind of new to, if this is the first time you're kind of dipping into it, having a look at these, as well as the book Continuous Delivery, which was written by Jez Humble and Dave Farley, which is kind of the Bible for this stuff, really. So today's talk is about organizing for continuous delivery, and the point of that is basically around, so what do we do with our teams and our people? How do we kind of make sure that they're set up in the right way to really effectively do continuous delivery? So let's take a step back before we get into the meat of that, and just think about some background on continuous delivery, or what it's all about, really. So Jez Humble has said the quote that's here. The basic idea is to kind of make releasing painless and reliable as possible. The reason we do that is A, in the first instance, it reduces risk and the cost and all the hassles that normally come with releasing software. It's one of the most painful points, really, of the software kind of delivery process. And in order, the thing we get out of doing this is beyond reducing the risk and the cost, is to give flexibility and adaptability. And the way that we do it is, as Jez says, about making sure your software is always deployable. So every change that you make, you try to do everything you possibly can to it to make sure that it is ready to go live at any point in time. I like to make the analogy of kind of keeping your room clean. You can kind of let it go and wait until you have some big event where somebody's going to come over to visit, and then you've got loads of work to kind of clean it up. Or you can just kind of clean it up after yourself as you go. And as that kind of analogy implies, it's a matter of habits, right? I mean, it's really, not all of us have great habits when it comes to, cleaning up after ourselves. But as a software delivery organization, it really gives a lot of benefit to kind of develop and build those habits and as discipline of making keeping your software always ready to go. So, in the industry, there's a lot of kind of stuff that's driving into this. I thought we would talk about continuous design and continuous delivery as a loop, and as complementary kind of ideas. And there's a lot of kind of trends going on in the industry around that are kind of the all pressures that are coming in for organizations to be able to move quickly and think quickly and react quickly and adapt what they're doing. And there's these ideas of things like the lean startup from Eric Ries, and so agile analytics, so the big data type stuff, A/B testing and multivariate testing that you can do with software to kind of get very quick and very detailed feedback on what users are doing, how they're actually using your software. And at the same time, so these are kind of enablers. You get all this kind of enabling technology underneath that. You've got kind of cloud stuff. You've got infrastructure automation and DevOps ideas. And these are all kind of providing, in essence, the tool sets that let us meet that need to change and adapt quickly. So it's kind of all these kind of forces coming together that kind of make this a really interesting time and really enable us to do the kind of stuff we talk about with continuous delivery in a way that maybe we couldn't do previously. And the key point is that the focus quickly goes to the technology when we talk about continuous delivery and DevOps and all that, particularly because most of us in this area we're technologists, and so it's the easy thing to think about. And it's also the easy thing to focus on is we're going to automate our testing, we're going to automate deployment of software, we're going to automate how we configure our environments and infrastructure so that they're all consistent and highly reliable. And that's probably not. It's important. Obviously, it's a keystone to doing this. But just putting that technology in place isn't going to get you the benefit that it can offer. So I've got a number of books that I'm going to kind of call out as kind of interesting, useful references and things that kind of contribute to some of the ideas in this presentation. And this one, The Modern Firm by John Roberts, is a good one. And I really like the idea of complementarity that he talks about in there. And this is the idea that different practices kind of work better when they're used together. And I think with a good example is, and a relevant example for this conversation is with agile software development. You've got a lot of practices, things like iterative development and iterations and test-driven development, continuous integration, all those kind of things. And you'll often find in organizations that are doing things in a more traditional way, more kind of, what we say called waterfall way, is that if you try to kind of pick some of these, random practices from Agile, that sounds like a good idea, let's try doing test-driven development and kind of bolt it into our existing process, you often don't get the full benefits. And in some cases, it can even make things worse, and you end up kind of duplicating. So if you decide we're gonna still do big requirements documents and then technical specifications and have that kind of process of spending months kind of investing in bolting down what you're going to build before you actually start building it. And then you get into the development phase and you decide, well, we're going to iterate and we're going to kind of adapt and change stories as we go through. You're potentially kind of throwing away effort that you invested earlier, and maybe even having to spend extra effort in order to sync up. If you want to keep those original documents accurate, you've got to go back and make changes in multiple places. And so you can actually come out worse than if you take things in a kind of piecemeal fashion. And in John Roberts' book here, he's got a good kind of story about the automotive industry in the 80s that really illustrates this. So, of course, in the 80s, the American big manufacturers like GM and Ford and so on were really struggling. And the Japanese manufacturers like Toyota and Nissan were doing really well. And so there was a lot of kind of focus on this, a lot of, what are these guys doing better than us? So folks from GM went over to Japan and visited to see, how are these guys doing stuff? What can we learn from them to go do things better ourselves? And the big thing that kind of jumped out at them, the thing that they kind of focused on when they went back and said, what should we change, is the automation. And, that factory floor that you see there in that picture, they saw, they've got a much smaller workforce, producing cars at a much faster rate than we are, and that's what we've got to focus on. That's what we've got to replicate. But there's actually a lot more going on. People who are into kind of lean and all those ideas are well aware that Toyota has the Toyota Production System, TPS, which is the basis for a lot of their thinking around lean and also heavily influences Agile software development. And it encompasses a lot more than just having that automated factory line. So, for instance, the American manufacturers, their assembly lines, they were producing the same car. Every car that came off the line was exactly the same as the one before it. And their product development process, the design process, was a very long one where they spent a lot of years working out what they were going to build and then setting up the assembly line to build that. And then when they wanted to change it, it was a very long process and a lot of work going on. It's obviously very analogous to what we're talking about with continuous delivery, this idea of being able to adapt. Because what the Toyota folks were doing was each car that came off could be different from the one before it. It could be varied. This is what the automation was giving them, was that flexibility. And the design process could be much quicker and more adaptive. They can get changes into what they were building much more quickly, and then they could keep their inventory levels very low. They were also using a lot of complementary practices, like the workers being enabled and empowered to take control of how they do their work, because they've got the best information there on the floor. And so the ways that they work, they had a lot of control over. But and also supply chain integration, taking their vendors and integrating them into the process so that they could do just in time and again keep their inventories low and everything like that. So when GM went back, they invested loads and loads of money in building automated factories, but they still did the same thing. They still pumped out cars exactly the same one by one. Still had very long design processes for their products. And so they ended up losing just buckets of money. They really didn't see the benefit. In fact, it was worse because they spent so much money on the automation and didn't see the benefit from it. And obviously those things have moved on since then, and they've gone a lot further. But it's a good example. It's a very relevant example for continuous delivery, because this is very similar to what happens when an organization has got continuous delivery and says, let's do that, focuses on, let's build the technology. But actually the kind of limiting factor for continuous delivery is actually more of the people. It's more about how we organize the work and how people do what they need to do, how they get the work done. So getting that right is important, and there's a lot of people obviously involved in delivering software. And in the typical process, they're kind of involved in a very sequential manner. You have people do kind of the kind of requirements analysis, and then moving on to technical design and then implementation and then testing later on. And things can go through a lot of phases, especially after in the release phase. Things can move through a lot of kind of different groups. And with continuous delivery, people have to change the way they work, because the focus is less on handing things from team to team and doing a lot of manual validation of work that's been done, and then deciding, so when you find that something's wrong, well, what do we do about it? The focus is on doing stuff up front, building the quality into each piece, so doing small pieces of work, and then just constantly, as we go, constantly doing whatever kind of validation is needed, and ideally automation enables us to do that and do it rapidly. But it does mean that the way that people work has to change, and often the organizational structure makes this difficult. So the first step is to kind of analyze how we currently work in an organization, how the work kind of proceeds through it, so that we can think about how we might need to, what kind of changes we might need to make to take advantage of continuous delivery. So a useful technique for that is value stream mapping. And Mary and Tom Poppendick have written several books on that, lean software development, which are, so this is kind of another school of agile software development. Agile Scrum has kind of a lot of attention. There's also kind of Kanban and Lean and various other things, which have kind of different takes on it. Still follow the principles of Agile. But the lean software approach is very complementary to continuous delivery. So I'd highly recommend that if you're not from, if Scrum is kind of your, where your awareness is of Agile, that you have a look into this stuff. And they talk about, in this particular book, Implementing Lean Software Development, they talk about value stream mapping, which is a concept from lean manufacturing, to analyze your flow of work. And the focus is on lead time. And I think when it comes to continuous delivery and metrics, this is the most important metric, the most useful metric. And that is, how long does it take for one idea, not for a release of software, but for one kind of functional change that has some value to the business? How long does that take from somebody raising that up and saying, hey, this might be a good thing to do, to actually not only getting that in production in end users' hands, but getting feedback, getting data on, well, are people using it? Are they getting use out of it? Are we getting the value that we thought we would get out of it? So getting that time down, that's the really kind of valuable thing, and the kind of benefit that we can look from for continuous delivery. And traditional software development goes, again, that waterfall model goes in batches, where you have a bunch of different functional changes, features, and maybe some bug fixes and things like that, which are grouped together and they proceed together throughout. So they go from kind of the different phases all together, and no feature is left behind, no change is left behind, which also means that no change kind of moves more quickly than the slowest change in that batch. And as well, when you look at the lead time for an individual piece, and let's say your release takes about 6 months to get through, and if you look at one feature, one functional change that has value, how long did it take? If it took 6 months, how much time was actually spent working on that feature? It's actually probably very little. Most of the time was spent waiting for other stuff to get done, and that's, in lean terminology, that's waste. That's it's inefficiency. So what we aim for is flow, and that's the idea that just each feature moves through the process independently, and so that we can achieve a good rate of work and get individual changes through the system fairly quickly. And if you focus on flow, you find that overall the whole process can become a lot more effective. The challenge to this is the handovers. When you've got various teams, and the structure of your organization is such that pieces of work have to be passed from one team to another, you end up with a lot of handovers, and these do have a cost. There's transaction costs of handing things over. When you think about what has to be done when something is handed over from one team to another, let's say I'm in the database team and got a request and you set up a new database server for a test environment, for example. What has to happen is, first of all, I have to specify, if somebody's going to request something from me, what has to be in that request. And then, so somebody's got to do a bunch of work on putting that request together and making sure it's right. Then it gets handed over, and there's quality checks on, is everything right in there, everything complete, is it complete, does it have the right stuff in it. And you've got to do the work, you've got to hand over documentation with the work, you've got your deliverables and everything, and then there's got to be more testing around that. And there's all this work that goes on, and you end up, it's a lossy process because you lose knowledge when this happens. When you pass things from one team to another, knowledge gets lost. And you also get things where, so something gets handed over and you test it and it's correct, and you realize this isn't actually what we need some change to it, or it just wasn't done right, and you get kind of debates over, well, you didn't say that in the specification originally, you didn't say that wasn't in the request, to change requests, got about this budget, that budget. You get a lot of time and effort and energy going into things which don't actually add value. Nobody really cares. To be honest, nobody even really cares how much testing you've done. What they care about is that the output, the outcome, is a high-quality product that's correct. And the amount of testing, the amount of time that you spent testing doesn't have value. If you could do loads and loads and loads of testing and still put out something that's rubbish. And if you do that, nobody really cares that, well, you've got this document that shows that you did squillions amounts of testing, and they're not going to give you kind of extra credit for that. It's still, they don't want the product if it doesn't do what they need. So we need to kind of think about how much of the activity that happens is really a useful thing. So another useful book, another interesting book is The Spin and Command and Control from John Seddon, which he talks about systems thinking, which is basically a lot of the same concepts as Lean, but he applies them to specifically to service work, so it's quite relevant. And one of the things, I think one of the key points here is that you have to think about the system of work, and you divide things between these teams and the way that people behave. It's very easy to kind of blame the people for not kind of taking responsibility and taking ownership and doing the right thing, even though the focus is on kind of their own part. So I'm responsible for the database. If you ask me to set up a database in a certain way, and it's actually not the best thing for the product as a whole, it's easy to say what I hand over is fits the specification, but doesn't give what the product really needs. It's kind of easy to point fingers and say, well, you're just kind of lazy or whatever, but you're working within the system that's there, and you've only got the kind of visibility of one small piece, and you have to deliver what is expected of you. You're going to do that, and you have to think about, rather than kind of pointing fingers at people, you got to think about, well, what is that system that they're working in? Is it really set up in the most effective way, or is it set up in a way that just makes it so that people kind of have to do something which might be suboptimal? And so now we can get into talking about that was a lot of kind of ideas and stuff that feeds into things. So if we talk a little bit about team structures and some ways that work. The classic divide in IT is between development and operations. And we'll get into the fact that it's actually a lot more, most organizations gets a lot more complex than this, but there's a DevOps movement which really focuses on this as the kind of main conceptual divide that you see. So development is focused on getting functional changes in, bug fixes, new features, and so on. And then you've got the operations side, which is focused on support, keeping the system available and making sure that it's operating well. And this is it's kind of a sensible thing to do in a way. It makes sense that we organize things this way because there are kind of different concerns. But another way to describe this is you've got one team that creates bugs and another team that works around the bugs. Because you often do see, so you go in and look at the way people are working in an operations team, and you'll find that they are focused on working around issues that are in the software. So an example is, see a team where they get a software release, and it turns out it's got a memory leak in it. But it's a very slow memory leak. It takes a few weeks, maybe even a month, before it becomes bad enough that the system becomes unusable, falls over or whatever. So there's a pretty clear workaround. They restart the system, or maybe elements of the system on a rolling basis, so there's no downtime. They can do it once a week in a period of low activity, and that works around the problem. And then you've got the development team, so you put in a request, the operations team puts in a request, there's a bug, there's a memory leak in the software, and you need to fix this. But then the operations team kind of loses sight. They tend to lose sight of those things. We just kind of accept the condition that, the software is buggy, it's got all these things. How can we be more effective? When we talk about automation, go in and do consulting, when we talk about automation with some of these operations teams, you'll find that they're often focused on how can we automate, that server restart so that it's being done automatically and we spend less time doing it. That's really the wrong thing. You don't want to be spending your time automating, working around problems that exist in the system. And again, going back to the systems thinking thing, it's very easy to point fingers and say, well, that development team, they're lazy, they gave us buggy software, and they haven't fixed it, and they're not fixing it, even though it's been months and we told them about it. With the operations team, it's easy to kind of come in as an outsider and point at these people and say, wow, they're not focusing on fixing the root cause of problems. That's really not, that's not really very good, is it? But they're kind of, each side is doing what they're doing the right thing from their side of things. From the development team's perspective, yeah, they've been told there's a bug, there's a memory leak, but you know what? There's a workaround for it. It doesn't actually bring the system down. And from their perspective, they've got software, functional changes that the business needs. The business is saying, we need to do this in order to make more money, to save costs, whatever it is, that has real value. Why am I going to deprioritize some of that work in order to fix a bug that's actually not causing any disruption? And so everybody's kind of doing the right thing given their perspective, but the fact is that, overall you get this kind of lower quality, and you get, I think one thing that's quite interesting is, here in the UK, where for the past week there's been a major story in the news where one of the big banking groups in that West, RBS and Ulster Bank Group, kind of major IT issue, and it's caused huge disruption. They're in the papers, and their staff have had to work in the branch offices all weekend, and that's, we don't know what's caused that, what the original cause is, but you can kind of see in working in these organizations where you're in this state of bugs exist in the software and they're kind of accepted, how you can get into that kind of situation. And that's that memory leak. Nobody's actually looked into it to see what's causing it. And it's very easy to imagine that some other change is going to come through, whether it's a minor change in the software, something in the infrastructure, which is going to kind of interact with whatever that root bug is that's actually wrong and causing that memory leak. And suddenly you go from crashing every month to crashing every hour, and then you can't, that your workaround doesn't work anymore, and you've got a disaster on your hands. So this kind of structure of the development and the siloing of things extends, kind of more and more layers and ways of dividing things up. So there's a classic thing in ITIL. It talks about, for service management, framework for service management. It talks about the kind of phases that systems and services go through of design, transition, and then kind of operations and support. And a lot of people interpret this, although ITIL doesn't actually say you need separate teams for it, a lot of people interpret it as you should have separate people doing these separate things. And so that's kind of the classic thing that you see coming into organizations where they start getting split out and start adding more handovers into things. When you get the divide between the kind of software side application and then the infrastructure being separate divides. And before long, in an organization of much size, you end up in something that looks like this. When seeing this exact kind of siloization where it's just chopped up, diced up in all these different ways, in particularly large organizations. And it's funny because I think there's a belief that this is inevitable with large organizations. If you've got thousands or tens of thousands of people in your IT function, obviously you have to organize them in some way. You have to have different reporting lines to make it more manageable. And the logical thing is to kind of divide it up in this way in the kind of functional roles. I have to challenge the idea, though, that it's inevitable that this affects teams doing products in the way that it does. Because when you go into an organization like that, and you see that if you focus on one particular thing that they're delivering, a service, a product, whatever it may be, you'll often find that the people who are doing the work for that particular product, there's actually only a handful. There might be like 50 or 100 people at most, if you really look at it and really pare it down. And so that actually is like a small company, because when you talk about like DevOps and let's bring all the people together on one team kind of thing, you'll hear, that's fine for startups and small companies, but for a big company, it's not possible. Well, it is possible if you've got that. If you look at it and find there's actually only a small number of people working on the thing. The issue is that at the kind of macro level, when you're looking at all these people, these hundreds or thousands, tens of thousands of people that you've got to organize in some way, the way people tend to do it is along the functional lines and say, let's put all the kind of people who deal with servers together, let's put all the people who deal with databases together, and so on. And so when you look at that team of 50 people, you're drawing the lines kind of within that group of people. So this is one group that's delivering something that has value to the business, but then you're kind of chopping it up into, several or a dozen or more different organizations with different reporting lines. And the issue with this is that once you've got those divides, you have to add in things to manage those divides. You have handovers to do. It's divided responsibility and accountability, and each group has to make sure, if I'm responsible for databases, and I'm going to be setting up databases, I have to make sure that I protect myself. I have to make sure that if somebody puts in a request that, I've got a form that says exact information they need to provide, and I'm going to provide exactly what they've asked for, and then I'm going to hand it over with exactly what, handover documentation and deliverables are necessary. And that's all I kind of can, I have to kind of protect that little piece. And nobody has the kind of responsibility, the overarching responsibility to make sure that all of those things work well together. Or more to the point, nobody has the capability, the authority to kind of take all that group of people who are delivering something and make decisions that affect all of them on delivering that product. If you go up and use these larger organizations to have the structure, and in order to find somebody who's got responsibility over all of those 50 people within that team, you end up pretty much at the board level. You end up with people who have responsibility for those thousands or tens of thousands of staff. And then, of course, that project of 50 people is a very small thing. They've got no real kind of detailed visibility, understanding of what's going on in that. So that makes that project suffer. And not only that, but because of all these handovers they have to have, you take that 50 people, and you start needing to add in project managers and more kind of testers and all kinds of overhead in order to manage that. And that soon blows up to where you've got 100, 150 people dealing with that product. So what are some ways we can avoid the issue? So going back to the original development and operations guide, the classic DevOps or the NoOps concept is that just have everybody together, everybody who's delivering a particular product together in one team, and kind of with accountability, shared accountability and a kind of single point of ownership of that. And I think that's what we're aiming for. That's kind of the goal, although it is challenging in some ways. So oftentimes we need to kind of take some creative approaches to kind of building that effective unit, even though, for instance, so going back to the database folks, and maybe that team doesn't need a full-time database person, and actually, there are a bunch of teams that need database people. You can't have a full-time dedicated database expert on every team. So you start thinking about things like, can you kind of rotate people in where people are kind of shared, or use secondments for key points in time, or even kind of virtual teams where you say, okay, we've got those functional teams, the database people, systems people, and whatever else. We're going to kind of have people who are a part of the project and come together on that project. But I think the important thing in these kind of this kind of approach is that those people need to have their agenda set by the delivery team, the team that's actually trying to get something of value delivered. This is something we'll come back to in a little bit. I'll come back to it here, really. The team that's delivering the product has to have the end-to-end ownership. They have to be the ones who are responsible. If they build something and it doesn't work right, they have to be the ones who are going to experience that and have that knowledge of how it works in operation, and have that cohesive end-to-end responsibility. And they also have to have behavior ability. They have to have the ability, when they need something done, to not have to kind of go up to somebody else and ask somebody else, can you do this for me? Can I be allowed to do this? Because that's what slows them down. That's what kind of stops them from being really effective as a delivery team. So the obvious question coming out from that is, well, then how do you make sure that the quality is there? How do you make sure that people aren't just doing whatever is kind of expedient? And there's this concept of extrinsic accountability versus intrinsic. So the extrinsic is the idea that it's a traditional idea. It's you've got people in a team with a focused responsibility. You're responsible for the databases, you're responsible for the systems, whatever it is, and you're accountable because you've got a checklist and you've got documents and things which tell you this is what you're supposed to do and this is how you're supposed to do it. And so people take responsibility for that. They take responsibility. Well, I'm doing what I'm told to do because that's what I'm accountable for, and that's what I'm going to get either rewarded or penalized based on. The intrinsic accountability, if you've got the same people who are running the code are the same people who are going to be woken up in the middle of the night when that code falls over, they have the accountability because it means something to them. they're responsible for the whole thing. If it's wrong, then they'll suffer. Then there's the question of how to scale this. It's easy to talk about it for small companies and think about how that would work in a small organization and a larger organization. There's a lot of interdependencies between different delivery teams doing different things. So how can you scale that? I think the overarching thing I'd say is simplicity rules. Just like with software and with systems, the more complex it is, the more things there are to go wrong, the more things can fail. So it's important to look at what is the minimum viable team. So looking at your organization and what it supports, what it delivers, services, products, whatever it may be. Try to work out what the minimum viable thing is. There's that minimum viable product concept, which is what's the smallest thing that we can develop functionally and deliver to get value out of it and get feedback from it. I think there's a similar concept with team. What's the kind of smallest team that will have something that it can own and that it can deliver and be responsible for that has some meaning and some value. And that can be difficult. I mean, things can be quite, in organizations that have been going for a while and are quite, have gotten quite big, it can be difficult to do that. But I think that's a worthwhile thing to do. It's not something that can be done in isolation. So like a lot of things with organizational change, it's not just about changing one thing. You will have to think about, for example, the technology, your enterprise architecture. How does that work? In order to kind of have teams that are small and loosely coupled, so that they may have dependencies, but each team can kind of proceed on its own. You have to think about how your systems are structured, and if they're structured in a way that makes that very difficult, then probably that's an issue of its own that you need to deal with. You need to think about how can we structure our enterprise architecture in a way that is looser and that gives you other benefits in terms of how quickly you can change your systems. And there's also technology that comes into, again, continuous delivery. Some of the stuff that's talked about in the book and in some of the other talks, which are a lot more technically focused in this one, do address those kind of things of how to manage the interdependencies between different systems and different software. There's also an idea that, so if you do have separate systems and separate delivery teams, but then you've got some kind of new thing that you want to do that's going to cross over and touch a lot of them in a way that several different things of each team need to change things. It might be worth considering a kind of a temporary team where you pull people from each of those main delivery teams, put them together into a room and have them work together on that larger change. And that way you've got the people in the room who understand the systems that are being affected and can make sure that decisions that are made around the design and implementation are kind of appropriate and will work well for the various systems involved. And then also, assuming there is a temporary initiative, once it's pretty much kind of there and in place, so as people go back to their own teams, you still have that end-to-end accountability. It's not like the kind of thing where you hire in external people and they build something and then go away and don't necessarily have accountability for it. You're sending people back to their teams, their original teams, and they've got that, they're the ones who are going to have to support it, whatever changes they agreed to make and made. And that temporary group, they're going to have to deal with the consequences. So that gives them, again, that ownership. And then another point is that, so we're talking about these kind of independent delivery teams. We're not talking about kind of chaos. We're not talking about these teams. You get a bunch of different teams to go out and do whatever they want, however they want to do it, and do whatever is kind of expedient for them. You still need to have kind of cross-team. You can have like communities and kind of review processes that go in, so you're sharing knowledge and again, I'm liking talking about the database folks as an example. So if you've got kind of database people in these different teams, they can get together and decide we should standardize on this and that, and it's going to kind of that's what's going to work well for their individual teams. But it's driven by the delivery teams. Now, when you get into that place, you then start thinking about, should we have teams, centralized teams that manage kind of tools, infrastructure, those kind of things, and provides those as a service to the delivery teams? And that can be a good idea, although it is kind of dangerous. You can reach the point where you end up with kind of this silo. You have a DevOps team. It becomes another silo and another kind of handover. You see some places where they have release management teams that are just kind of rebranded as DevOps. It doesn't actually change the way things happen. So the concept can be good, but there's some important guidelines, I think, to doing this right. I think one key thing is that these kind of tool teams, infrastructure teams, whatever they are, they shouldn't be involved in that delivery flow. So there should be nothing, nobody should be depending on them to do something in order to get routine work done, to get routine software changes through. And the things that they do put in place, the ownership has to do with the delivery teams. So one of the kind of anti-patterns you see is where you get these tool teams, you get a bunch of people who are sitting, and not actually the people who are using those tools, and they decide, right, we're going to use this tool. We've seen a presentation from the sales folks, and it does everything, ticks all the boxes, so we're going to buy this, and then all the teams will have to use it. And then it turns out to be something that actually makes everybody's life very difficult and makes it difficult to deliver software effectively. So the delivery teams have to have the ability to say, yes, I'll use that tool because it works for me, or actually, no, we need something different. And for this to work really well, those tool teams, infrastructure teams, platform team, whatever you call them, they should respond to this by kind of going and working with the delivery teams and saying, right, how can we help build a tool that works for you? So rather than kind of sitting in their own office somewhere else, churning out tools for somebody else to use, they're working with those delivery teams. They're seeing how the values and the design and implementation of those tools being driven by the people who are going to be using them. Netflix is a company which has used this concept quite well. They talk about NoOps. So DevOps is a big trend these days, but NoOps, they say, we don't have an operations team at all. And they actually do have what they call a DevOps team, and what they do is they provide a platform as a service. They provide the kind of infrastructure on a self-service basis so that the delivery teams are able to deliver the software, they write the software, they are able to do things like hooking and monitoring everything, because remember, these people have responsibility for it in production as well. So it's in their best interest to make sure that they can monitor it well and get information, when things go wrong or what they need to do in order to improve their software. So I think that's an interesting case and something to look at. And that's kind of the main bulk of what I wanted to talk about. There's a few books here that I mentioned during the talk or referred to. And also there's a couple of links for things like the Netflix NoOps thing and a few other things. So this presentation, we're going to put the slides up on the ThoughtWorks website so that you can download it and have a look at these things if you're interested in. So I think we've got a bit of time for